You know that in September, we had a webinar, our System Dynamics Society pre-college special interest group had a webinar on giving a demonstration of how to use artificial intelligence in creating causal loop diagrams or stock flow diagrams. Um, the causal loop diagrams were created in Co-Model, which is a free causal loop diagramming software. And the stock flow models were created in Stella, which there is also a free version of Stella that has the artificial intelligence. Stella can also create causal loop diagrams. So it has the artificial intelligence. So we showed that a month ago. So then this presentation is about what kind of guidelines should we, how can we make best use of artificial intelligence when we're actually having students use artificial intelligence to build causal loop diagrams or stock flow models? And so that's this particular presentation. But they're shorter. It's not a webinar. It's like a 7 to 10 minute presentation, and there are two of them. One for stock flow models, which would be mine, and another one for causal loop diagrams. Since there are only three of you here, three new people, I was thinking you're more interested in causal loop diagrams than in stock flow models. Maybe we should only have the causal loop diagram part and not the stock flow diagram part. So you want them both, or you want just the causal loop diagram part? Why don't you decide on that? One presentation instead of two presentations. What do you want? I think both of
Is
you
there,
only use causal loop diagrams, right? You don't use stock flow models.
um,
Is that correct?
no idea. Yeah.
Oh, do you?
Yeah. Well,
Oh,
I
okay.
mean, yeah. I mean, I try to.
Okay. All right.
Yeah.
How about Hattis? Um, I are you actually there? Hattis Atik?
I think it is pronounced as Hatice.
Oh, Hatice?
No.
Is it a Turkish name?
I think so.
Oh,
Yes.
sorry about that.
Hmm.
Okay, Hatice, would you prefer to hear both the stock flow diagram and the causal loop diagram presentation, or just the causal loop diagram presentation?
Emre hocam. Emre hocam.
Evet, buyurun söyleyeyim. Ben şey yapayım.
Ee, hocam kusura bakmayın. Ya ben anlıyorum ama tam ifade edemeyeceğim.
Tamam. Sadece stok akış mı yoksa yani stok akışı anlatayım mı anlatmayayım mı diye soruyor. Hani
Aa, stoka
stok Hı,
stok akış evet. Ya ben hepsine katılıyorum. Çok güzel dinliyorum da. O yüzden hemen açtım. Yani konuşmalara katılamam ama dinliyorum.
tamam ben şimdi onu çevireyim. Tamamdır.
Tamam. Çok teşekkür ederim.
So I'm translating now. Uh,
Aha,
and she says, I can understand, I can transcribe it, but I cannot speak in English so very well. So let me try to help her. She's preferring both of them,
okay.
if you can.
Okay. Is that all right then that we do both of them?
Yeah, I want both.
Sure.
Okay.
That
All
sounds
right.
good.
And mine is going to be live since I'm here,
Yeah. Yeah.
and the other one will be a recording. Now, this is guidelines. How can we use AI the best way that we know right now? Because this is going to change as we get more experience. The best way we know how to use artificial intelligence to help with building stock flow models and with building causal loop diagrams. Okay, so I'm going to present my part now. I have like 6 slides, I think. Can you see my slides?
Yeah.
Yes.
Okay, good. This is guidelines using AI to build small stock flow models. Now, we must remember from the last presentation a month ago that Stella has two different ways of using artificial intelligence. There is the build part, which allows you to give a prompt in words and it builds a stock flow model for you. The build part that is quantitative mentor, which means you can ask the AI questions about your stock flow model, and the software will add to your model or, you know, look for mistakes in your model. So that's one way for stocks and flows in Stella or for causal loop diagrams, because Stella also can use AI in causal loop diagrams. Oh, excuse me. And of course, Stella Online is free. So there is a restricted version of the software that is free for you to practice on. But I'm not going to show the software. Then there is the discuss part, which is really just like a mentor. You can ask the software, what do you think the stocks should be? You can describe a problem. What do you think the stocks should be? And it will give you some ideas. And you could say, okay, I think these 3 are good, but I don't like these 2. Now, can you tell me some relationships, some feedback? So you can ask like a tutor. So that's the Selden mentor. And then very powerful, and I think that Stella is the only software that can do this, the discuss Selden part, you can run your model, and with the special loops that matter feature, and the AI will explain to you what the behavior, why the behavior is the way it is based on the feedback in the model. So that's the capability of the AI in the Stella software. Here are some problems using AI in building stock flow models. Oh, we're going backwards. Okay, no, I don't know what happened. Sorry about that. Try to go forward. Some problems. Students may not know that AI can give you misinformation, that it can hallucinate. Students may not know that. So we have to pay attention to that problem in what we do with students and artificial intelligence. Why is this going backwards? Okay, students may not realize that AI can be biased, and so in its responses may not consider, say, a population of young people or old people. They may not give you model pieces that have all the people, considered, or they might not consider it special people of special ethnicity or indigenous people. So we have to realize that AI can give us um, biased information when it builds a model. So that can be a problem. Students may not realize what AI has actually given you in a model. It may give you so many stocks and so much structure that you can't even understand what AI has given you. Or it may put mathematical definitions in each icon that are too complicated. The math is too complicated and shouldn't be complicated. It may not make good labels for the icons. So we have to be aware of this. The other thing is students may not use AI critically. They may think AI is just produced this, so it has to be right. And that's a problem. They may get into the habit of thinking what AI is giving them has to be right instead of critically analyzing what AI has given them and being the human who is analyzing this instead of just accepting it. So these are some things that we have to be very careful about when we're using artificial intelligence. Students must know some system dynamics before they use artificial intelligence in the model building process. And these are some things that they need to know. They need to know how to identify a systems problem, what mental models are, how to identify the assumptions of the model, the boundaries of the model, what causality means, what link polarity means. They have to know what a stock is and what a flow is and how to represent them. They have to know what feedback is and the two different kinds of feedback. They have to know how to build simple models themselves by hand, ones that produce linear or exponential or convergent or simple oscillation models, very, very simple oscillation models. They have to know those first, building it themselves by hand. They have to know how to define components and labels and equations and units. They have to know that structure of the model determines the behavior of the model. They have to know how to analyze their model, be able to explain the model behavior to different audiences, and they have to know the SD modeling process. If they don't know this, they cannot analyze what AI is giving them when it builds a diagram, a stock flow diagram for them, because they don't have enough background information to analyze it. So here are a few guidelines. System dynamics best practice says we should build our models in stages. Using artificial intelligence increases this importance because if you don't build a model in stages when you're using artificial intelligence, then you don't understand each piece and you haven't analyzed, are the pieces right in my first stage? Did it define all the components right? Did it label them all right? If you don't do that in stages, artificial intelligence can get away from you very fast and you won't know what your model is. You won't understand your model well. So students should analyze each stage to make sure that it is still connected to the real world idea, that it is defined with simple math and has correct labeling and correct link polarity. And so those things are really important. It must build in stages. And you can make some exercises that will help students start to be very critical of AI, which I think is important right from the beginning. Use exercises that show a diagram that has bad behavior in it. In other words, bad structure. Maybe give a model that has missing links or incorrect link polarity or poorly defined icons and have the students required to identify the mistakes in that structure so that it gets in the habit of when it's done, gets something from AI, it's automatically thinking, does it have any missing links or any of these pieces? You get them prepped for thinking about AI making mistakes. Also, you can give them some examples that have bad definitions of math in the icons and have them analyze how to fix the definition. Because for sure, AI is going to give them some bad math definitions in some of the icons. So they have to be thinking about the fact that AI could give them these bad things so they have practiced on how to fix them. You could give them a bad example that students, by having them already build a model themselves, a small model themselves, and then ask AI to build a model and look at the two models and analyze what's good and what's bad about the AI model compared to the model that they have built themselves. So they start to be very critical about what AI is giving them. The other thing is AI is based on probability matching, not on always doing the same thing every time you ask it to do something. So you should ask them to have AI build models at different times during the class period because they probably will get something a little different to help them realize that AI is not deterministic. It is stochastic, which means it's built on probabilities. So it's not always going to give you the same response. So that's another important thing that should be part of the work that you have students do when they're using AI with model building. These exercises train students to expect AI to make mistakes, so it enhances the students' critical thinking when they're working with artificial intelligence. Now, there are some really positive things that AI can provide in helping students in the model building process. In mentor mode, now you know mentor mode is that like quantitative mentor in the build part or Selden mentor. It's kind of like when the AI is giving you some information, but not all the answers and asking you some questions. It's like the Chat GPT has a new version, a new subcategory now, teach and learn. So it doesn't give you so much. It's like a tutor that is asking you questions as you converse with it. That's what mentor mode is. But that's also part of the Stella AI. In mentor mode, AI can help the students come up with an idea for a model. It can help the students come up with a good problem statement for a model. It can guide students through the modeling process by doing, it can help them understand more about the problem. So you can ask the AI to explain some things about the problem to you. It can help clarify their understanding about a subpart of the model. Maybe they understand part of it, but not another part, and you can ask it to the AI to give you more explanation about a subpart of the model that you don't understand. They can use AI clarification. So once the AI has given more explanation, you can take the AI explanation, put it back into the background information that is a part of what you are allowed to do in Stella, so that the AI, that background information can be used to help build the model itself. It's a way of kind of teaching AI. You're using a response from AI to help you go to the next step in building the model. The AI can help students identify components to use in the first version of their model. It can help you understand what stocks to use. It can help the student produce good prompts. So you can ask the AI, please give me a good prompt for, and then you describe a problem. Give me a good prompt. I want to build a model to study this problem. Give me a good prompt so that I can put it into the build part and it will give me a good, uh, a, a better chance of getting a good model. And some of the things on getting good prompts is be specific as to what you want. I want a model of a bank account that has a savings account and a checking account. And I mean, be specific about what you want the AI to help you build. Identify your role. I'm a math teacher. And I want to use this with my 10th grade high school students. So you're identifying the audience. Identify the format for the response. Well, um, in the build part, it's going to actually give you a stock flow model that it has put link polarity on and all that sort of stuff. In the discuss, it can give you explanations of things. And maybe you tell it, give me a paragraph explanation so I can explain this to sixth grade students, this model to the behavior to sixth grade students or to high school seniors, or give me a bulleted list. So there, you can go online and find good ideas for making prompts. And that's very important when you're working with artificial intelligence. In mentor mode, AI can help students divide a large problem into a sequence of smaller models that, in other words, you can ask, you can tell it a problem you want to model and say, I want to build this model in 3 separate steps. So tell me what the first step should be and what stocks I should include. Tell me what the second step should be. What stocks should I add, et cetera, et cetera. It can help students come up with other examples for models that produce the same behavior, but a different discipline. One thing we say in system dynamics is that structure transfers across disciplines. And so, for example, the epidemic model is a structure that transfers really well to selling a product in business, or of course, the epidemic model is the spread of a disease, but it could also be in social studies, the spread of a political movement or something. So these are the same structure will work in different disciplines. So you can ask AI to help you figure out how to transfer a structure to a different discipline. It could help students develop more precise feedback explanations. Students are not very good at explaining feedback at the beginning, and so they can use AI to get better examples of explaining feedback. It can suggest sensitivity tests for you to use on testing your model. It can identify potential policy interventions. It can provide explanations for different stakeholders. You know, a fishing model, maybe you're talking to the fishermen, or maybe you're talking to people who sell the fish to companies or something like that. Um, you can use it to, you can ask, you can use AI to ask it to fix a problem in your model. And I did that as an example in my September presentation. I had a bank account model and I asked it to fix a problem in it. And it actually fixed a different problem that I didn't even expect. And Kareem Shishakli, who is the second speaker, said, be careful if you're not really precise about this, because he said he asked it one time to do the same thing, and it gave him a whole bunch more stocks. And he said, "Oh, that's not what I wanted." So you have to be careful. You know, you could say just one more stock, or just add a few pieces, or something like that. You got to be a little careful about not giving it enough information. And of course, using Stella Selden and loops that matter. This is, people will know loops that matter if they've used the Stella software. That can, artificial intelligence can explain the model behavior based on the feedback in a model. That is such a powerful application of artificial intelligence for model building. Here are a couple of other guidelines. Students should always identify where and how they used artificial intelligence in building their model. And actually, it's already built into Stella. Stella has a little feature that will tell you which pieces of the model were built by AI and which pieces of the model were built by the student. So that's kind of cool. What model structure did AI produce and what did the student produce? And they should show, students should show the prompts that they used. But of course, you can copy that from the property panel that AI provides when the AI explains that. It can be copied and put into a paper. Students could be asked to reflect on what parts of the modeling process where AI was helpful and what parts were not. So these are just a whole bunch of ideas where we have to be really careful on some of the problems that AI brings into the classroom and other places where it can be really useful in the modeling process. Now, I was in a group called, I was on a team in a committee called Using AI in SD Education. And a white paper was written by this group over a period of 4 months or 5 months. And this white paper happens to be available for free. All the stuff that I talked about in my presentation came from that white paper. It's a big explanation of how to use artificial intelligence, things to consider for building causal loop diagrams, for building stock flow models. And this is the URL. It's on our System Dynamics Society pre-college webpage and this is how you get to it using this URL. And on the main page, news is at the top, and it's the very first item under news. You can click on it and and download a copy of the paper if you are interested. Now, so that's really the end of my presentation, but I would like something came up last September that I thought was an interesting piece of information. So this is kind of a separate thing that I thought might be interesting to you. There is a blog that I found out about last time, an interesting blog for people interested in systems thinking and system dynamics, Loops Behind the News by Kim Cassens and Tim Shipley. And if you're looking for some information about articles for loops in the news, you might be interested in looking at this particular blog. So I'm just providing this. And my slides are provided with the video of this. So I am now finished. You could take just a picture of it. You could just do a screen capture if you are interested in having this. Okay, so I'm going to stop sharing. And I think what we should do next, before you ask any questions, is we should show the causal loop diagram presentation that Kareem Shishakli presented in the first meeting. And then we can have any questions and answers if that's okay. So thank you. Emre, do you want to show
Yes.
Kareem's?
Okay.
Okay.
And,
This is just a video because for him it's the middle of the night, so he's not going to present.
Yeah.
okay.
Okay, so there's going to be some overlap with what Diana said because we are both authors of that white paper. So you'll see there's some overlap. In any case, my name is Kareem Shishakli. I'm at IC Systems. I'm also at WPI. And I want to start with the desired student skills that we're looking for. And these are critical thinking, first of all, and second of all, an open mind, not just in what you see from what the AI gives you or what other people tell you, but also about what you generate. Keep an open mind about everything you generate. You should question the AI, of course, but question yourself as well. We want students to be able to understand a model and its behavior, and that includes CLDs, the ability to explain a model, causal links, feedback, delays, why it behaves the way it does, And we also want them to keep control of the modeling process. Diana talked about, if you give it a prompt, it could generate something you can't understand. That happens all the time. If you want to do anything, you want to do it in small steps with the AI, or you're going to get in trouble. As Diana pointed out, students still need their core skills. If they don't have the core skills, they cannot evaluate what the AI is giving them. And we also need to teach them to create good prompts, or ask the AI to give them good prompts. We want to focus on in-class exercises for the core skills so that we see that they're not using the computer, and then you can extend it using AI in homework exercises. And of course, you want to make sure they always indicate where they've used AI and show their prompts. These are the steps in the modeling process, and AI can be used in all of those. They can be used in defining the problem, drawing the reference mode here, although they can't actually draw it, developing the dynamic hypothesis, which is a causal loop diagram. Diana just talked about this stuff. And also policy experiments, you can check about policy even with CLDs. There are several ways to use the AI. Diana went over a few. One of them is to generate a clear problem statement, which you then feed to the AI, by the way, because it needs a problem statement. Generate background knowledge, which you also can feed it, but you should verify it. Generate a dynamic hypothesis, or CLD. Generate a sequence of steps to build a model, and it can give you the prompts as well. Critique the model or your CLD for completion and accuracy. Debug your model. Actually, you can ask it if there's something wrong with your CLD. Analyze the model's behavior and suggest and evaluate policy options with implementation details. And again, you can ask it that about CLDs as well and see what it does. To build an AI prompt, you need a clear description of what you want it to do. You need to be very specific, and you need to give it the context. What is the situation we care about? Why do we care about it? You need to tell it who the audience is. Is it a high school student? Is it a legislator? Is it whoever it should be? You should give it whatever sources you want it to use so it doesn't just go out into the whole wide world. And you need to be very clear about the format you want the answer in and how large it should be. So I want a paragraph, I want 2 sentences, I want a table, I want a bulleted list, I want only 4 stocks, etc. Here's a sample problem formulation exercise. So this would be the first step toward building a CLD and then perhaps a model. Given this news story, create the problem statement and identify the key stocks in the system. This is something we expect them to do without use of AI. They should create the problem statement and identify the key stocks on their own. Then the next step is for them to develop an appropriate prompt to ask for the problem statement and the key stocks, and then execute it. Critique the AI response and identify how it differs from yours. This way, students can learn what the AI can do, what it can't do. They can learn to think critically about the AI, and they can also get feedback about their own work, because it may raise questions they hadn't thought about for the work they did in the first step. For this example, I'm going to use this story from NASA on the collapse of the Mayan civilization. It's not on their website anymore, so we have posted it here. And that I'm going to use that link directly. So that link goes in the background knowledge that you give it, and I say, this is my prompt, give me a 2-sentence problem statement from the background knowledge. The background knowledge is just that link. And here's what it gave me. And if you read this, you'll find it went way overboard, and it took stuff that wasn't necessarily even in the article. It didn't just use the background knowledge here. It started talking about causes and whatever. So I did not use this problem statement it gave me. Sometimes it gives me one that's okay. Sometimes it doesn't. You need to be able to read that and think about it and say, does this make sense for my problem statement? So I just used a simple one. What caused the Mayan civilization to collapse, which is all we're looking at. So I did not use what the AI gave me. I used my own. And then I still want the key stocks. So I put the problem statement in there, same link for the background knowledge, and said, using the background knowledge, identify the key stocks that led to the collapse. And it gave me this answer, which is an amazingly good answer. Population, food supply, water availability, forest cover, and soil fertility. By the way, only the first 4 are needed to explain the reference mode, which we didn't talk about how you get the reference mode. I won't be talking about that today. The next exercise is how do we generate a CLD, or dynamic hypothesis, actually. Create a dynamic hypothesis for the system using only the stocks you've already identified. The student is supposed to do that on their own first, right? So they do that. And then they create an appropriate prompt to ask the AI to do the same thing using only the stocks, right? So you may wish to feed it the stocks it already identified, and you should explicitly limit the number of stocks, or that you identified. It doesn't have to be what it identified. Next step for the student, critique the AI generated CLD. Does it make sense? Does it match your mental model? Is it missing anything, or does it have too much of something? And then the next step, the student can modify their CLD or the AI CLD to match their new understanding after going through this exercise. So I did this using only the background knowledge, which is just that link to the article and the problem statement, of course. Create a dynamic hypothesis for the system, including only stocks and using no more than 5 stocks, because I want a dynamic hypothesis and that should just be stocks. And 5 is actually a big number for a dynamic hypothesis. In any case, it gave me 4. And if you notice something, this does not really match the list of stocks it gave me. It gave me a list of key stocks before, and this is not it. I mean, population is here, just renamed it. So it did not generate what I was hoping for it to generate. So I went back and I copied its list of key stocks that it gave me. That was in Selden, by the way. And this is in the qualitative engine, which Diana didn't talk about. She just talked about the quantitative. This is in the qualitative engine. I copied the key stocks that it gave me into the background knowledge. So now it has the link and it has the key stocks. And I also told it to limit it to 4 stocks. So I gave it the same prompt, but I just said 4 stocks just to see what it would do. And I added to the background knowledge. And now it gave me something that actually made sense, that actually uses the background knowledge. I don't know if anyone noticed, by the way, so societal stability was never mentioned before, and I don't believe it's even in the article. So it's, making stuff up. Anyway, here we have a decent CLD. It gives us a description, which I didn't include there, but it gives us a full description of what's going on. And the CLD makes sense as population goes up, forest cover goes down, water availability goes down, food supply goes down, population goes down. And you can ask it all kinds of questions about this. You can ask it, to identify the loops, which it can. And actually the Stell software will also, you don't need to ask it if you don't want to, but you can ask it to do that. You can ask it to critique it. Give me a critique of the CLD, blah, 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 blah. But notice, and here I saved my model, but this could be of my CLD. Generate a bullet point where that bullet point gives you a short title of the problem. Give me up to 2 sentences on the issue, 1 sentence describing why it's important. Focus on the scope of it and its applicability to the problem statement. Raise any other important issues. So that you can use that for CLDs. You can use that for models. For feedback explanation, if you have a model, you can put data in there, run loops that matter, and get one. But you can also ask it for a feedback-based explanation for why the population collapsed if it didn't already give you one at the end of generating the CLD. And there we go. Wow. Did this yesterday too. Okay, so policy suggestions. Again, you can use it for a model, but you can also use it on the CLD. You can ask it to give it some ideas on how to prevent overshoot and collapse or whatever you want it to do. You can ask it to provide an explanation for whatever your audience is, right? So for example, provide an explanation for the collapse of the Mayan civilization for a college environmental studies major, and it will give you one, which is great. And of course, generating a background knowledge, I didn't show you that, but we can ask it, because I already had it, give me a bulleted list of concepts and relationships that I should include in my model. Okay, for some reason, clicks are not working here. Here we go. So we have AI, we're gonna need to use it. I didn't show you this, but you wanna use small iterative steps, and you can build your models, even your CLDs. If you want to build on your CLDs, small iterative steps, it can create junk very, very, very quickly. And modeling, you need to understand modeling to identify what's going on. And that's it. I'm just going to stop there.
Okay, so now you've seen the presentations that we did in the first meeting. If you have any questions, we would be happy. I would be happy because Kareem is not here. I would be happy to answer any questions if you have any questions. I knew most people are not using artificial intelligence in their classrooms yet. It's just so new that it's going to be a while, but we thought it was important, since AI is here, that we try to see if we can provide some preliminary guidelines for how maybe we can use it well until we get more experience and find out what well really means. So we just thought we would try to present this as some ideas for getting started. Do you have any questions?
I don't know. It's more, I guess, a comment. I mean, I found it, it's really helpful, and just understanding the process of it, and just even like it when within your talk, Diana, with like I didn't. I guess I really just didn't think of like as saying, "Well, I'm a high school teacher doing this." I'm thinking more of that like ChatGPT or one of or but that obviously would be helpful with putting that in and then just breaking it down, all the steps is really helpful. Because I've tried to play around with it just myself, just trying to build some things, and then for the class and realizing, well, many of those steps I still need to pay more attention to get the result I'm looking for. So yeah, thanks.
I think what's going to happen is we have to play with it ourselves. We have to try to build some things ourselves. And then as we experiment with trying to build some things, we get some ideas of how we might want students to use it. At least that's the way I learn. I try it myself and I go, oh, this will make a good lesson. I think
Mm.
I'll try to have my students do this piece.
Yeah, that makes sense.
But we're just getting started for one thing. And this is one thing Kareem said. He's been playing around with AI for 2.5 years.
Oh,
I've
wow.
only been playing around with it for 1 year. He said he's been playing it with 2.5 years, but it was only this last year that AI was good enough to do anything with it because it made so many mistakes in earlier versions that it wasn't really worth your time to do much with it. Now it's worth your time. So now we have to try to figure out how we might make best use of it.
Yeah.
But we need to experiment, and that's going to take some time. If I were doing this in a classroom, I would experiment with a few kids that I really liked and who liked me and who were willing to give me some good ideas,
Mm.
or with a class that I liked and maybe I had a little time that I could let them experiment a little bit. But
Mm.
anyway, I think teachers are not there's a delay for the new technology with teachers. They need to start feeling comfortable themselves before they're willing to kind of bring it into the classroom and do something with it, I think.
And I think
But
that advice uh, about first you try, then compare it with the AI, that might be very helpful
I think so.
because
I also like the idea of giving students some models or causal loop diagrams that have mistakes in them.
hmm,
So they're always looking for the mistakes. And so when they work with AI, they're expecting mistakes. So
Yeah.
they're always looking for mistakes when they're working with AI. I
Mm.
think that's so important. They just get in the habit every time they're working with AI, they expect mistakes. So they
Mm.
get real critical. They should be critical of
That
the
should be.
AI.
Yeah.
And we've got to get them in the habit of that. So I think some of those exercises that you give them that have mistakes in the diagrams make them um, looking for mistakes all the time is important, I think.
Yeah. Makes
Yeah.
sense.
So, well, I don't know. We gave you the information, and maybe it just needs to settle in a little bit. It is on our website if you want to look it over. And both Kareem and I provided our slide, excuse me, our slides. So you could look at those as well if you're interested in trying to look at the information again.
Yeah.
Yeah,
No, that'd be great. Thank you very much.
sure.
And yeah, like I'm actually gonna try this on my last project of my class actually. So because I've
Great.
been so kind of like just feeding them or trying to go through without, they don't know about the AI that's in Stella, but so up to this point, so just so trying to help them, build models and try to like you said, try to as much as I can to teach them, how to do it without it. And then the last project, then kind of show them this, and then
Yeah,
so the slides would be awesome to help guide
great.
them. So with along with that, so yeah, thank you for both of them.
You're welcome. You're welcome. We don't know yet what we're going to do in November for our, either webinar or presentation because I've asked a couple of people if they're willing to present a couple of times and they haven't gotten back to me yet. So I have a backup, but we don't know for sure yet what's going to be the November um, presentation. But I think if either way, I think it will be something that will be kind of interesting. I hope it's
Yeah,
interesting to me. So we'll
yeah,
see. Um,
sounds
if you
good.
don't have
Yeah.
any other questions, I think we can call it a night, or for me, it's a night, but we could call it an end of the meeting. Is that all right?
Like, I guess one question:
Okay.
do you know teachers that have already been like they teachers? Yeah, do you know other teachers that are K to 12 that are already using this? Like,
The
um,
AI.
the AI, yeah,
You see, that was the presentation that I wanted to have in November. I wanted some teachers who are using AI to present about their experiences,
yeah,
but I'm not getting responses, and I think it's because they don't feel confident enough to
right,
talk about it, and I don't want to push them. So maybe that would have to be something for a later
right,
date,
yeah,
when maybe they feel, but that's the next thing I thought. Let's see, because I do know a couple of people who are using it,
okay,
but they're not responding to my emails. So I think it's going to have to be my backup
yeah,
until they feel comfortable enough. Maybe we could get them to do it later in the year.
yeah,
Yeah,
okay,
so sorry about that.
sure, yeah, thank you.
Okay. Well, have a good time. It's a good night for Alan and for me, and it's a good day for the others of you.
Okay,
So, okay.
Okay.
great.
Goodbye.
All right,
Thank you.
Bye.
thanks
Thank
everybody.
you.
Bye.
All right,
Thank you very
Mhm.
much.
Bye.
Bye
bye.
bye.